I wanted to do a couple of examples called what they call the multiplication rule, in which we're going to multiply some probabilities. I want to do a couple of examples similar to the homework. So here's an example. An alarm clock has a failure rate of 5.8%. So then they ask a question. A, find the probability one clock fails. Well, that's 5.8%, and they probably will want their answer expressed as a decimal, which I can convert the percent to a decimal by dividing by 100. So that's 0.058. B, find the probability that two fail. Well, now the probability that the first one fails times this probability, the probability that they both fail is the probability that the first one fails times the probability that the second one fails. So that's 0.058 times 0.058. If you like, 0.058 squared will do that. So on the calculator, if I go 0.058 squared, about 0.003 to 3 decimal places. And the third question, find the probability that 3 of them fail. Well, the probability that 3 of them fail is going to be 0.058 times 0.058 times 0.058. So that's going to be 0.058 to the third power. And on the calculator, 0.058 to the third. Now that gives me 1.95112 e minus 4. 1.95112 e minus 4. Now that's scientific notation. That's the same as 1.95112 times 10 to the minus 4. And 10 to the minus 4, that minus 4 tells you to put 3 zeros in front of there. So that's the same as 0.000195112. And I don't know, in the homework they'll probably ask you to round that off. So that's one example of the multiplication rule. One more example is in acceptance testing. So suppose that, here's another example, 28 of 861 light bulbs are defective. A buyer accepts the whole batch if 3 randomly selected bulbs are good. So the question is, find the probability the batch is accepted. Well, the probability the batch is accepted is the probability the probability the batch is accepted is the probability of getting 3 good ones. And by this multiplication rule, this is the probability of 1 good one raised to the 3rd power. And the probability of 1 good one you have to calculate because they gave you 28 of 861 are defective. So the probability of 1 good is the number of good over the total number. And because they gave you the defective ones, the number of good is 861 minus 28. That's how many good ones there are over the total number. So that's, on the calculator, 861 minus 28 is 833 over 861. That's the probability of 1 good. So to get the probability of 3 good ones, I'm going to raise that number to the 3rd power. Probability of 3 good is 833 divided by 861 raised to the third power. So on the calculator, I'm going like this: 833 divided by 861. And to raise to the third power, I'm using this caret over here, which is an exponent key to the third power. And that gives me 0.906 correct to 3 decimal places.